Hello everyone, welcome to Remote Development with CLion. Welcome to my little island. If you can see my slide there, there's a nice picture of an island. It's about 1,100 miles off the coast of Antarctica. The reason I've chosen that picture, this is Bouvet Island. Apparently it's the most remote island in the world. So just a little pun there. It's also significant because I think if you ever got stranded on that island, there's you're going to be pretty open to the elements. There's plenty of things that can go wrong. And I think that's a good metaphor for the type of demos I'm going to do today. There's lots of moving parts. I've got about 3 or 4 different VMs, a VNC session. There's even a VM within a VM. Lots of things that can possibly go wrong. Hopefully it's all going to go smoothly. But if not, just bear with me. So what I want to start with is just to go over some of those topologies, as we said. And I want to start just with the simplest possible case, just to get our grounding and a place to start from. Just talking about normal development, just on a local machine, as we might do during a normal development cycle. And there's a few components that we need to have to make this all work. And we usually take them for granted, so it's worth just specifying them. So first of all, of course, we have a set of source files. That will be the your C++ code files, header files, things like that, as well as build files and so on. And then we have a set of tools. We normally call that a tool chain, as we have a number of tools that we need to make this work, not just the compiler. And the result of applying those tools to the sources, of course, produces a set of binaries. There may be artifacts along the way, but we're just going to concern ourselves with the binaries for now. That's the executable product of the compilation stage. But also, if we're doing development for what we call debug builds, we'll generally have a set of debug symbols as well, if we want to actually step through code and see the source code alongside it. So nothing out of the ordinary here. Just want to establish the components that we're talking about. So that's development on a local machine. Then when we introduce a remote machine into the mix, this is where we can get a few different ways that we can put this together. So the simplest possible case is something that we've probably all done, which is where we just deploy our binaries to some other machine, maybe a server or another desktop. And we may do this from our own machine, or it may be from a build server or something like that. But the principle is the same. We built the binaries on one machine, and now we're copying them to another machine, and that's where we're going to run them. Again, so far so good. And then something goes wrong, and we need to actually debug that. And obviously, the simplest thing is if we can reproduce it on our local machine, and we'll do it all there. But sometimes we can't do that. Sometimes we need to actually debug on a target machine, someone else's desktop or a server or a VM or something like that. So what we might do is copy over our debug symbols as well, or maybe we've distributed them alongside the binaries in the first place. And then we start doing debugging on our deployment target. We'll also need at least some of the source code on there as well, so we can see what we're doing. And of course, we'll need some tools, not necessarily the entire tool chain, but at least debugger. So we'll probably be using something like GDB on the remote machine. And we can do all of this, but I mean, as you can see from the diagram already, there's a lot of moving parts. It gets quite complex, a lot of things to keep in sync, and maybe we can use tools like rsync or SCP or something like that to help us. But it's a very tedious process. A lot of things to go wrong, and it's not much fun, to be honest. If we have to do this from time to time, that's fine. But if we're going to be doing this on an ongoing basis, we really want something that's going to make that whole process easier. And of course, that's what this webinar is about. So if we're running CLion locally, we can actually switch out GDB on the remote machine for GDB server. And for 2 or 3 years now, CLion's had a feature called remote debugging that will actually connect to GDB server over an IP network and do that part for us. So that means that we can debug as if we are debugging on our local machine, but the debugging is actually going on the remote machine. All of the other parts stayed the same. We still have all of these different components that we have to keep in sync. It's a little bit fiddly to set up, but this can still be a very useful way of working, and we will have a demo of this a little bit later. But that's the first step, is just remote debugging. But actually, you're still building and developing locally and then deploying, and then it's only the debugging stage that we introduce the extra tooling. So then we go on to the new feature as of 2018.3, which we call remote development. So Now CLion will go over SSH. Now, if you've been around software development, particularly on Linux or Unix machines for any length of time, you probably know that this is just the way that remote development is done. It's over SSH. But usually that's all command line, all in the terminal. But now with CLion support, you can actually get the full benefit of having an IDE and also the benefit of doing development over SSH, the best of both worlds, if you like. And as you can see from the diagram, it's a lot simpler. Now, really, all you need on the local machine, apart from CLion itself, is your source code. And everything else happens, all the tooling, the binaries are built on the remote machine, the debug symbol is already there, there's nothing to copy over, nothing to keep in sync. Except, of course, you still need the sources on the local machine, so you can actually develop there and edit your code without having to round trip all the time. So CLion also does that for you. It actually manages the syncing of the source code, usually using rsync on Linux machines or Macs. On Windows, it's a slightly different approach, but basically the same. So once you set up remote development, it's as if you're editing all your files locally, but everything else happens remotely, all managed for you by CLion. And again, we will have a demo of that to show you exactly how that works. Now, there's still reasons why you may want to use the remote debugging approach, particularly if building on the target machine is very slow or expensive. And a good example that we'll actually look at is building on a Raspberry Pi. The demo we do is going to be quite small, but obviously anything more substantial can be very slow to compile on a Raspberry Pi. So you may want to do your development on the local machine and then cross-compile, so actually build for the Raspberry Pi or whatever your deployment target is locally, so you'll need that tool chain locally, and then do the remote debugging step that we talked about earlier. So let's say we'll have a demo of that as well. So in that case, that's the missing step, the cross compiler that we didn't talk about before, and we'll come back to that a little bit more as we get into the demos. That's really my introduction, just a high level view to talk about some of the different flavors that we're going to talk about today. That there are different variations on this, and we don't cover all of them yet. So going to and from different architectures, we currently only support going from a Mac or Windows machine to something Linux-like, including the Raspberry Pi. But there will be other options coming in the near future. So coming out of the slides, now this is actually my desktop. I've put one of the slides for the backdrop there, just so that we can keep track of where we are. So we're going to be going into a remote debugging demo here. And what I've got here, hopefully you can see that, is CLion running locally. I'm running on my Mac. This is running Mojave, so I'm running dark mode. So that's why we have that color scheme. And the demo I'm going to use for all of these, actually, the code demo is going to be this really simple Hello World program, really, because we're not too interested in what the code is doing so much. But what I've done here is making some POSIX calls to get the current host name and then just print that out. And that's useful because now we can see a difference depending on where we're deployed. It'll actually be visible when we run the program, so that's quite useful. And we can even see that in the debugger as well. We've got a cmakelist.txt file there as well. As you can see, there's nothing really going on there. It's compiling for C++ 14, but that's only because it's the default. There's nothing unusual about that. So what we're going to need is a remote machine. So here is a VM that I've prepared earlier. It's an Ubuntu VM. If we log into that, you'll see I've just got a couple of console windows open. What I've also got here, if I show you the directory I'm in, you can see I've already got that source code copied over. So remember I said for remote debugging, we have to manually keep track of copying source files backwards and forwards. So in this case, I've got them locally. I've built them locally as well. And if I just show you that file there, we can see it's the same one that we have over in CLion. It's just an exact copy. Okay, so obviously we can run that. here, and we can see I set the host name to something that we can relate to easily. So hello parallel world, because this is running in Parallels on my Mac. So coming back to CLion, what we can do here is, in fact, you can see the run configuration I've got here. It's just a normal run configuration. I haven't got anything going on just yet. If I build and run that, that's going to just run locally. So here we can see it's printing out the host name of my Mac, Zoanon, which is actually one of the computers from an early Doctor Who, if you're interested. What we want to do is of course, get this to debug the code that's running on the Linux machine. So if we go into Settings, the main things we're interested in are all under Build, Execution, and Deployment, and we have tool chains and then the CMake profiles. So under tool chains, yes, I'm jumping ahead a bit. We don't need to touch that at all for the remote debug. We can do that all in the run configurations. And if we add a configuration for the GDB remote debug, give that a name. Let's call it remote GDB. So you can select which GDB you want it to run, and the bundled GDB multi-architecture should do us fine for this. And then we start getting into the more fiddly bits of setup we need to do. So we need to provide the connection to the Linux machine. So we'll need the IP address, and that's why I've got this ipconfig running here. It's the IP address that we need. So it's TCP and then 192.168. That's going to be running on port 8080. And then we need a symbol file. And what this is where the debug symbols are going to be stored. That could be a separate file, or it could be the executable that was built with debug information in it. Now, I've already copied that locally. Again, that's one of the files that we need to keep track of and sync ourselves. I'm just going to put the path in to where I've copied that to here. And then we need to provide path mappings. So this is for the root folder or the root directory of our source code on the local and remote machines so that they match up. So again, I'm going to copy these paths that I prepared earlier. So that's the remote path, which was what we were running from earlier. And then the local path is this one. And that's telling me something doesn't exist.
You have a wrong IP. You have to check it.
Oh, yes. Yes.
You need a dog.
Thank you for that. Pair programming, can't beat it. That doesn't seem to be enough, though. Okay. Pretty sure that's the same string, but there we go. So, with that out of the way, I should be able to debug that now. You see I've got a breakpoint set on the C outline. In fact, I've missed a step, because I also need to run GDB server on the remote machine. So listening on port 8080. Now I run from CLion on the local machine. And you can see it's now remote debugging from the host. And over in CLion, we can see it's got the host name. Now, for some reason, when it's running GDB server, it's not able to expand out the string, the char star, but we can see the characters there. We can see it's got the parallel world hostname. So that's remotely debugging from CLion on my Mac. And if I just run that to conclusion, we can see now it exits. So not a particularly exciting demo, but it does show that communication between the local machine and our Linux VM. So let's go on to something a little bit more interesting. And we're going to do basically the same demo, but now instead of on Ubuntu, we're going to do it on a Raspberry Pi. So it's not just a VM now. What I've got here is a VNC session into a Raspberry Pi that I've got connected across the room. Again, let's get the IP address there. So it's 204 this time. Then in theory, that should be about the only difference. So if I go into my config and just change that 201 to a 204, do also need to change the symbol file to this one. Hope it accepts it this time. And then the remote folder and the local folder should stay the same. No, there's something wrong again. And it's not showing me what it is. Let me just check that again. Okay. And again, I need to run GDB server. Did I run it earlier? There we go. So exactly the same. Listing report 8080. If I now run that from my local CLion, it's connected. Again, I have to look into the characters, but we can see now it says Raspberry Pi. So that's picked up the hostname from the Raspberry Pi itself. And I can run that to completion. There. And it completes. And says, hello, Raspberry Pi. Now, what I glossed over here, of course, was how we built the Raspberry Pi binaries in the first place. So we're just doing remote debugging here rather than full remote development, which we'll get to in a moment. So what I would do is actually build them in CLion itself. And the way we can do that is to set up a CMake profile for it. So make this debug. For Raspberry Pi. And I'm not going to touch the toolchain because what we're going to do is override it here. There's a few ways to do this, but I found that the way I got this to work was to use a separate CMake file with all of the toolchain info in it because it gets a little bit involved. There may be a way to do this more cleanly in CLion, but this is the toolchain file. So we can see we've got the GCC, G++ binaries for building to ARM v8. And the root directory specified there, so it also picks up all of the libraries. And by putting that in, passing that on to CMake, it's then going to use that toolchain for building. Now, those binaries, by the way, I downloaded pre-built binaries that still work on Mojave. If you're trying to do this yourself, particularly if you're listening to this later, most of these binaries, if you look around on the internet, you'll find lots of tutorials that use this cross-tool ng tool for building cross compilers, and all the instructions seem to be for that, which currently still work, but apparently just last month, the developers of CrossTool announced that they're no longer supporting the Mac. So it may be that support for the Mac with that tool stops working at some point. It's still working at the moment, as you can see. Let's see if I can actually build with that now. We have the configuration there. And in fact, yeah, built straight away because I'd already built it earlier. But that has built it using the Raspberry Pi toolchain. And then, as I say, you can manually copy that binary over to the Raspberry Pi. I use SCP in this case to copy it, and also use it for the debug info. Okay, so that was remote debugging, both to Linux and a Raspberry Pi. What we can do now, if I bring the Ubuntu VM back, here we go. What we're going to do now is set up full remote development. So again, using the same code example, this is where we bring in the tool chains. So let's add a new tool chain. And when you do so, you can see this drop down on the right. There's only two options actually: system, which is the normal default, and remote host. We obviously want remote host. So then we set up our credentials, including our connection. So again, get the IP address. Then the username is parallels. And I'm not telling you my password. And then what you'll see is it will go away and it will look for in all the standard locations for the tool chain that it needs. So it's found CMake. It's found GDB. It's just looking for the rest of the tool chain. Now it's found them. So if you have your tools installed in the normal locations, they all need to be there already. You have to have set that up. Obviously, make sure they're the versions that you want. If they're installed to different locations, of course, you can override any of these and set that up more specifically. But that's sufficient for us here now. Then we go to add a new CMake profile. Make this debug again. And now we can select from the tool chain that we just added. It's given us a name automatically. We don't have to set that. That's quite nice. And now that should be everything we need. So we give that a moment to finish loading. There we go. So now it's using the debug remote host toolchain or CMake profile. So if we build that and run it, now we can actually see in CLion's own console window that it's actually outputting the output from the tool that's running over here on the VM. So we can see the host name there. So we don't even have to do the debug step. Of course, we can do that as well. We can debug into it, and we can see the host name has parallels world. Now, if we change this source code now, let's say just copy that into a char star, because then GDB is going to do a better job of looking into that. And if we debug that again, now you can see our debugger works down here. We even have the inline variables unique to CLion. So that's quite nice. But think for a moment what that's just done. We've just changed the source code locally, and it's synced that source code automatically behind the scenes for us, completely transparently, to the remote machine, and then built the binary on the remote machine, and is now debugging it on the remote machine all over SSH. And that was pretty transparent. I think that's a really smooth approach to remote remote development. So let that run to the end again. Just to prove that it is running on the remote machine, I'm going to set the host name to something different. There we go. Instantly picks that up. So we are running on the remote machine. It's just so fast, at least in this setup, that it does look like we're doing everything locally. So let's do something slightly more involved, and again, bring our Raspberry Pi VNC session back in. I can find that. Here it is. So, similar story. We're just going to change the configuration, which was here. So we just change that to 204. The username is now Pi, I think. Yeah. And the new password. And there we go. Again, it's finding the tool chain automatically for us. Again, I've got everything installed in the default locations, so that's fairly straightforward. But it's the same story. We can configure that if we need to. Always seems to take a bit longer to find the specific build tools. You notice here, by the way, it's found CMake 3.7.2. That seems to be the latest one that installs on Raspberry Pi at the moment, as far as I can see. I think you can install a later one. That's less than the current default when you create a CLion project, so you may need to set that back, which is what I've done in CMake lists.txt. Set it back to 3.7. Obviously, you can experiment with installing a more recent version. So let's build that. Here we go. Have to keep an eye on the taskbar at the bottom to make sure it's finished setting things up sometimes. So we run that now. Here we go. Hello, Raspberry Pi. And again, we can debug that. And again, we have our inline variables now coming from the Raspberry Pi. Again, all being edited locally. And all we had to do was just change the IP address and the username and password. And everything else just happened for free, basically. So while we're here, if we have a look in the Raspberry Pi, I'll just put everything in the root directory for simplicity. You can see our main.cpp file there. If I print that out, and you can see, yeah, it's exactly the source code that we've been editing over here. Sorry, that's not exactly the source code we were editing over here. What I meant to show was this. In the console, it shows where it deploys the source code to when it's automatically syncing it. So if we go there, there we go. There we go, that's more like it. And there we see there's that line that we added. So it's just copied that file over for us automatically. And we can see from our local CLion where it's copied it to. So that's both remote debugging and remote development in CLion against Ubuntu and Raspberry Pi. There's one more use case that I wanted to show you. I had a little bit of trouble with this just before coming online, and it seems to be working now, but just to warn you, in case it does go wrong. Over here, we've got another VM. This one's running Windows 10, as you can see. But it's not just Windows 10. It's also got WSL, the Windows subsystem for Linux. installed. I've got an Ubuntu session here. So this is that VM within a VM. If you can consider this one a VM, it's a subsystem rather than an actual VM. So it's a slightly different approach. Now you can use exactly the same remote development techniques that we just demonstrated. But the reason this is special is because even before we had remote development, we already had specific support for WSL in Windows. So we're going to settings. Again, you can see under the CMake profiles, I've already set this one up because I had those problems just beforehand. Debug WSL. It's just an extra toolchain, WSL. And if we now build that. So this is CLion running on Windows, but deploying to and running against WSL, again over SSH. And it's also transparent that it's actually hard to see that is what's happening. So we run that. You can see, yeah, that's just the host name. Now, because with WSL, it's running on the same machine as the same logical machine as Windows, we won't get a different host name to the Windows machine, so I can't demonstrate that. But the way we can tell that this is running on Linux rather than Windows is because these are POSIX headers here. This wouldn't compile for Windows. So we've been able to compile and build that, deploying against a Windows subsystem for Linux. By the way, the difference between WSL and full remote development is that because the Windows subsystem is not a VM, it is actually a subsystem. It is sharing the file system with Windows. So we don't need to do that syncing step. So it's a slightly faster turnaround, a little bit less complex. Again, because it's all hidden away, we don't really notice it, but that can be significant depending on the exact nature of your project. So I think I've talked enough for now. Those are the demos that I wanted to show. It's probably a good time to open up for questions, and maybe I can go back and show some additional things as necessary.
Yeah, thank you, Phil. So I will comment on some questions that we've answered here in the panel. There are quite many of them, so thank you. We'll try to answer all of them. There were a few more or less general questions that I would like to answer in voice. So there were questions about like for remote development on Windows with VSL, can we have sync to transfer the file? It will be much faster than SCP. So I would actually say that for VSL, you don't have to use the remote development configuration at all. You have to use the VSL toolchain, which is supported by CLion. And in this case, there is no like copying of the files happening in the background. So it's all much faster than just the remote development, like remote toolchain in that case. Also, maybe Phil, you can show the settings because this question was quite popular about how to configure the path mappings for full remote case, because when we configure in the remote toolchain, there is a default mapping created by CLion to the temporary directory on remote host, but you can actually change it in the deployment settings. So yeah, so here is the toolchain. Yeah, you can open it, and so here you have your deployment configuration created for this case automatically by CLion. There is a mappings tab. Could you open it? Yeah, and here you can see the local path and how it maps to the deployment path. So these are this is created automatically by CLion, but you can change it for sure. And so you can change it to the directory you prefer if you don't like the default mapping created by CLion. Also, talking about the full remote again, so there was a question about supported platforms. So just to clarify that for now, remote platform is only Linux, and local can be any like Linux, Mac, or Windows. So there was a question about if we plan to support Windows as a remote platform. We do. I think there is a ticket in our issue tracker We'll share it later in the blog post for those who are interested. And what was there important as well? Yeah, there was a question about the remote debug with GDB server, about how to provide the symbols in case of the shared libraries. That's indeed quite tricky because currently there is no good UI option in the configuration for that, and we have a feature request for adding this UI option. But you can work around it via the GDB need, and this workaround is actually written down in the corresponding ticket. I will provide the link later as well so that you can follow and check the workaround. By the way, I just remember one interesting question. There was a question about the LDB server. And the question was if we do support remote debug with LDB server. So I would say that we never checked that. So we're just looking at it now and thinking that it might work. We haven't checked that. So probably there is still some work to be done, some work that we have to do to make it work. So we'll probably check it in the future, but for now it's not possible. Only the GDB server is supported. And actually talking about the debuggers also, because there was a question in the panel that we do support custom GDB. So you can change the GDB to your custom binary, but you can't change the LDB. So we only support the bundle LDB version.
If you have used remote debugging before, especially from a Mac, it used to be a lot more painful, because the version of GDB that would work with this, well, it wasn't running on the Mac. You had to build it from sources with some special configuration options. Now the bundled multi-arch GDB works just fine in the cases that I've tried, so things are a lot smoother than they were.
Yeah, indeed. So there was also a question about the Docker. So currently we don't have any straightforward Docker configuration, but if you just use the remote with Docker, I guess it works. So we tried a couple of setups like that. So nothing special, no special configuration or some special setup, but if you just configure the remote toolchain and use it in case of Docker, it should work.
There was a question about cross-compilation. Somebody said that this setup is not cross-compiling, but compiling on the remote machine. Now, I'm not sure which demo in particular that was in connection with, but I did demonstrate it both ways. I did gloss over the cross-compiling bit a bit, because in order to try and make it run smoothly, I'd already done it earlier, and I hadn't cleaned that one out. So we didn't see it actually build, but I did build it locally on my machine, on my Mac, for Raspberry Pi, using the toolchain that I showed. That was the only cross-compilation demo that I gave, but of course, you can do that for other targets as well.
Yeah, actually, I would like to address one more question related to toolchains and the whole setup. So the question was if we can explain the relationship between all the settings like toolchain, CMake, and deployment. So currently, remote development works for CMake project model only. So that's why there is CMake in this configuration. So first of all, you have to configure a toolchain. So yeah, in this tab, so you create a toolchain, provide all the credentials, and then CLion detects all the CMake and compiler tools on the remote host. And so it will be using this environment and these tools to build your actual app. Then you go to CMake tab here below, and you create a CMake profile using this remote toolchain. So that means that CLion now knows that you'll be this CMake profile actually corresponds to the actual configuration we'll be running with this CMake profile, and so we'll be using this toolchain. And when you have this configured, when you have this CMake profile, now you have the deployment entry configured automatically by CLion. So these entries in deployment settings, they are created automatically. So at the time when you just configure the CMake profile that uses the remote toolchain. So and actually that's the general how the general configuration in CLion looks like for CMake. So we have toolchains which are general for IDE. We have CMake profiles which are configured per project, and they are they have information about the build types and about the toolchain used. And so when you select any configuration and then you select the CMake profile and you run or debug this configuration with this CMake profile, it uses these like build types and tool chains to do the job. So yeah, here is the switcher, and like in this switcher, you can select them. I hope that answers the general question. And there were also questions about like where to find all this information. I will show the link to the web help to particular articles, but in general, you can go to jetbrains.com/CLion/help and search there for all these tool chains and deployments and all the stuff. So I think that's mostly it. Yeah, here are the links. So you can find in our web help, you can find the detailed information on remote development and remote debugging with CLion and other articles you might be interested in. And more information can be found on our site and in our blog. And follow us on Twitter for news and updates and share your feedback. So thank you everyone for joining us today. If you'd like to learn more about upcoming webinars, just subscribe to us on Twitter, and we'll be happy to have you next time for the webinar. So thank you and develop with pleasure.